In this lesson, I'm going to show you how to switch from exponential form to logarithmic form and vice versa. The inverse of an exponential function is a logarithmic function. They sort of undo each other. Here's the definition of a logarithm. Let b and y be positive numbers and b not equal to 1. The logarithm of y with base b is written as log base b of y and is defined as follows. Log base b of y equals x if and only if b to the x equals y. The expression log base b of y is read as such. Log base b of y. In this example, we have in exponential form 2 raised to the third power equals 8. So yes, of course we know that if we multiply the number 2 3 times, it's going to equal 8. Now that is the exponential form. Now we can convert that to logarithmic form very easily. In logarithmic form, it is written as such. Log base 2 of 8 equals 3. So take a look at how we went from exponential form to logarithmic forms, and I will explain that process in more detail in the upcoming slides. Converting between exponential and logarithmic form. In this example, we're asked to complete the missing equivalent form. Here we're given an equation in exponential form, 4 cubed equals 64. That is the same thing as saying multiplying the number 4 3 times will equal 64. So in this case, 3 is the exponent to which the base 4 is raised to in order to get 64. So to write that in logarithmic form, we would write it as log base 4 of 64 equals 3. So you can think of it sort of like a snail. It kind of goes in a circle. If you look at it, you can see the exponent or the exponential form inside of it. 4 raised to the third power equals 64. In logarithmic form, we say log base 4, because 4 is our base here. Log base 4 of 64, so our answer goes here, equals 3, because 3 is the number that I have to raise 4 to in order to get 64. Let's do another one. Here we're given an equation in logarithmic form, and we want to rewrite it in exponential form. So when you're given it the equation in logarithmic form, we just simply take the base. So this is log base 1/2 of 8 equals -3. So our base is always here, so our base is 1/2. So when you write it, it's going to be 1/2 raised to the, it goes in a circle, to a -3 will equal 8. So again, 1/2 raised to the -3 will equal 8. So the way you write it in exponential form is such. So -3 is the exponent to which you must raise the base of 1/2 in order to get 8. Let's do another one. Here we're given the equation in exponential form. 10 cubed equals 1,000. So 10 multiplied 3 times obviously is going to give us 1,000. So write that in logarithmic form. We're saying that 3 is going to be the exponent to which we raise the base 10 to in order to get 1,000. So in logarithmic form, remember it's sort of like that circle. It's going to be 10 raised to the third power equals 1,000. And there you have it. Writing equivalent exponential and logarithmic forms. Let's do some more practice with these expressions. So here we're given logarithmic form log base 5 of 1 over 125 equals -3. And here again what we're saying is that -3 is the exponent to which I must raise the base 5 to in order to get 1 over 125. In other words, 5 to the -3 power equals 1 over 125. Next, we're given the expression in exponential form, 12 raised to the 1 power equals 12. So to write that in logarithmic form, 1 is going to be the exponent that I'm going to raise 12 to in order to get 12. So remember, it sort of spirals in a circle or in a snail-like pattern. 12 raised to the 1 power equals 12. Last example, we're given the expression in exponential form. 6 raised to the 0 power equals 1. We know that any number to the 0 power equals 1. And so here 0 is the exponent to which I raise the base 6 to in order to get 1. So to write that in logarithmic form, log base 6 of 1 equals 0. In a snail pattern, that would be 6 raised to the 0 power equals 1. And there you have it, writing equivalent exponential and logarithmic forms.